We're studying data structures and we're starting the lab 6Q1. Now, this is an online session because we don't have physical class. We'll just go through the questions. We'll look at the examples, we'll run the code, we'll try to understand what queues are, and then if you have any other questions, you can reach out to me. But the first question, it's just asking us to make a class, Q class, the generic Q class using linked list. If this is an implementation of Q using linked list, you could do it using array list. That's up to you. Implement the following methods. Okay, my Q, okay, DQ, get element, B, get size, contains is empty, to string, etc. Okay, fine. You have all of this going on. Perfect. Now write a test program that have an initialized queue items consist of durian and blueberry. That's a tester class. That's quite simple. Question 2 is just about checking. So we've done stack for palindromes. Now we're going to do queues for palindromes. That's quite okay. That's fine. Let's start with the first basic thing. Before we do anything, what is a queue again? A queue is basically this. Think of it like this. Both the sides are open. It's a queue. Items go in, items come out. So last in, first out is not this. That was stack. First in, first out is this one. So the first thing that goes in comes out first. Okay. However, if I compare it with stack, the comparison would be that LIFO would happen. You would have A, B, then A, B, C, D. The last that goes in is the first to come out. That's the difference. Okay, perfect. Now, the next thing you'll have to do for any data type is to know what kind of operations it can do. A stack can push, pull, not pull, while push and pop. Push, pop, peek, right? Now, what can a queue do? A queue can enqueue, dequeue. Yeah, let's see what else. Peek, enqueue, dequeue. Size, empty, to string, contains. So those are basic stuff. The main thing is NQ and TQ. Over here it's push and pop. Now, let's look at the code for this. This is the Q class. Let's try to run it. So, hmm. Hmm. Ah, okay. Hmm. Yeah, we don't have to do that. We just want to compile the question one. Okay, it's called my queue. Yes, it is. Right. Oh, run. Let's run my queue. There's obviously no main method. We need to run the tester class. Hmm. Oh, okay. So first, have a queue. That's the top item. Queue size is 6. Then let's look at the code now. Before we do the tester, let's see how we've done the different methods of queue. You've used a linked list. Linked list has nodes which can connect with each other. A node has a pointer and a value. The node points to the next pointer, our next node. Now, this linked list equals new linked list, okay? Um, my queue, make it, okay, done. This is just to convert the linked list of the queue to a specific type. Array of types. Now, over here, it's quite easy. It's quite simple as well. What we have is um, a default constructor. Now, this accepts an array of elements, okay? Now, maybe you don't have you don't have to make an empty queue. You have some list of items, some array of items which you want to use. So you can pass this, and it would automatically convert all those into a linked list. So basically what this has done is it has include all of these elements. Now you could have done it separately in a different way. You could have iterated over this and then done enqueue n times. Or you could just arrays.stream. So that means it takes all the values. Let's say it had 1, 2, 3. If it had 1, comma 2, comma 3, it would take 1, 2, then 3, and then it would add each of those to the linked list, which was initialized, which was created and which was declared, and now you're initializing. Now, public void enqueue, you add to the last. Okay, that's the same. We always add to the last actually in stack and queue. The only difference is where you remove it from. So in DQ, you remove first, you don't remove the last. Now, get element takes the item at the position which you want and returns it back. Peek looks at the first value and tells you the value instead of removing it. It does not remove the item. Get size tells you the size of the list. Contains checks if the item is present in the list or not. Finally, is empty checks if the item is, well, if the linked list has something in it or or is it empty. ToString converts your linked list into a string object. Now, we're done with declaring a basic queue. A queue is quite basic. It's just a linked list where you add from the start, remove from the back. Sorry, add from the back, remove from the start. A queue is nothing but a linked list or an array list where you add from the back but remove also from the back. Our tester class also runs. We've done some of the commands to test our program. This is important in your exam. Let's look at question 2 now. For question 2, they're asking us, write a Java program that uses a queue to determine if the input string is a palindrome or not. Now, to achieve this, you will have to look at the problem, that is finding if a string is a palindrome. The solution is quite trivial. It's just how you would do it with queues. Is it better to do it with queues? That's the question you need to ask. Now, most of the things you're doing are just math. It's problem solving. Data structures is just a use of, it's just a set of tools which you use to do the problem solving. Now, if you look at the main class, you have the words again. You want to iterate through them and check if it's a palindrome. Now, again, what you do is you're going to iterate from zero to mid, okay? So let's say if I have A, B, 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 A, that's a palindrome actually. Mid is 3. Well, mid is actually 2, 0, 1, 2, 3, 4. You will run it till 1, and you will check. If I run this from the back, will these be equal? What you've done basically is divided the text into 2 parts, the starting and the ending, the front and the back. If the front and the back are equal, that means that this is a palindrome. To divide the list first, you need to have the mid value. For that, they're doing left shift of bit 1. This is a tricky, a nice way of actually dividing by 2. Right shift means divide, left shift means multiply. Okay. Now, you add the first elements into the queue. Then you start from the end and you go back to the middle. You compare the items at the start and at the end. So basically, if you had A, B, 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 A, you would start from the left and you would go right. And this is for queuing. For comparison, you would start from the right and you would go left. Now, if they do match, then this is a palindrome. If they're not equal, you return false. If they are, well, if we didn't return false, that means you will have to return true at the end. So if none of them, if any of them don't match, then it's not a palindrome, and we're done. Let's look at the next question. If you want to see the code, I'll just show it again. This is the code. Now, question 3. When a share of common stock of some company is sold, the capital gain or loss is obtained by calculating the difference between the share's selling price and the price originally paid to buy it. This rule is easy to understand for a single share. However, if we sell multiple shares of stock but over a long period of time, then we must identify the shares actually being sold. A standard accounting principle for identifying which shares of the stock were sold in such a case is to use FIFO protocol. First in, first out. The shares sold are the ones that have been held the longest. For example, suppose we buy 100 shares at $20 on day 1, 20 shares at 24 on day 2, 200 shares. So basically, this is nothing but 2 queues. Then applying the FIFO protocol means that if 150 shares sold, 100 were bought on day 1, 20 were bought on day 2, and 30 were bought on day 3. Capital gain or loss in the case would therefore be 100 times 10 plus 20 times D, 20 times 6. See, you're doing nothing fancy, you're just multiplying them and adding them up. So 100 times So in this is quite simple. You need to understand um, when what was bought and how they were sold. 100 were bought on day 1. That's correct. $20 each. Now 20 were bought on day 2 and 30 were bought on day 3. Perfect. These are the prices. But simple actually. You're just comparing the difference in the price of purchase and Same. We're selling it at $30 each. That means over here it's a profit of 10, profit of 6, and then loss of 6. Loss, profit, profit. And then you just multiply by the number of shares. That's it. And you add it up. Write a program that takes the input as the sequence transactions of the form buy X share at this or sell X share at this. Assuming the transactions occur on consecutive days and the value of X and Y integers, give this input. Given this input, the output should be the total gain or loss of the sequence using FIFO protocol. FIFO means Q. This is the output format which you need to match. And there's a format for it. Sell X at Y each. So sell 60 shares at this much each. Let's look at the code for this. No, it's quite simple. It's not that difficult. It's doable. Now let's go through it. Okay, Java util Q, scanner, linked list. Okay, we need these, fine. We initialize the capital gain. We have a share queue, a price queue. There are two queues basically, right? Quite important. Okay, so while true, we take the transactions. We check if it's and then we give queries. Now, this one is, these are actually queries based. We will initialize it separately. We'll initialize the other things separately. Here, we're taking the query. These could be buy or sell. And that would actually add data to the queue. Now, when you have a query, first you need to check is it a valid query. For that there's another function. If it is valid, then you would parse the query, as in you would first split it using the gaps, and then you would parse it based on the gaps. This is input parsing, quite important, quite useful, quite simple, quite easy. Now, once you get all the information from the input, you would add it to the capital gain. To calculate the capital gain, you would just either do buy or sell, and that would retain the amount of capital gain. Now you're passing total capital gain as part of total capital gain because you want to update the value. You wanted to add how much the capital gain has increased or decreased. Now, this is the final one. That's at the end, and you're done. Let's see how you did the query matching. That's just regex. It's quite simple. You should learn that. Cell share, yeah, greater than 0. These are the requirements. It must be greater than 0. And then it must not, the queue must not be empty. If it's empty, you can't remove anything. If it's not empty, then obviously you just remove the first in, first out, the oldest one, not the most recent one in queues. Now, if share is greater than the share queue price, then it would increase the capital gain by doing Q share times price minus price 2. Now, next time you'll have to update the poll as well because the prices are not changed so that you can benefit from higher gains. Now, compared to 1980s, the prices of many things have increased. But that doesn't mean even though things are more expensive, we are more rich. So it's all about the work being done here. So total capital gain keeps adding up. Now, you take a peek and this will tell you how much you have solved. Just look at the code for some time and then we'll try to see how it works and we'll try to run it. Okay, we compiled it. And it's quite simple. When you sell the shares, let's just look at buy and sell, how it works. Buying means for now, you just print the thing. Okay, let's get back to it. Now, there's not much to explain in the code. It's quite basic. What we do here is we buy share and we sell share. When you buy the share, you add to the queue. Okay, you're buying the share, and this one shows us the share and the price. Now, when you do q.offer, it actually returns true or false. Add throws exception. if you try to add something to the queue. But if you try to offer it, it will say true or false if it was, and that would actually be the return of this if um, there is a return, or perhaps if there is unsuccessful operation, then you would get the return. Now, what's buy? Buy means you buy the share. You have share queue, price queue, share, and price. Okay. Now you print queue. Okay. So when you try to buy, what you're basically doing is you buy share, and then you add what you bought to the share queue and the price queue. It's basically happening simultaneously. So one by one. So the share and the price queue is now updated. The share and the price queue are updated with the recent purchase. Now, when you sell the share, you are going to see it from here. Now, this poll again, in this case, poll is just like removing something from the queue. Poll removes the item, and however, if the queue is empty and you can't remove anything, it would return null, and it would not really throw any exception. Poll is safer because it throws null and not an exception that would stop the program. You could handle null. Now, you calculate the total capital gain by the share which you're selling, the price at which it's being sold, minus the price um, at which it was bought. Okay, so this is the current price, and this is the price of it when it was bought. It's in the queue, at the top of the queue, actually, the front of the queue. So the difference at which you're selling now minus the price at which you're selling it now minus the price at which it was bought. In this case, what you're doing is you're subtracting the share. Let's say you had 100 shares and you sell 50, that means 50 would be left. Now, you can't really edit items in the queue, so you have to add a new item and then move the other items accordingly so that the last item, the front item is edited. This basically means that item in the front, okay, was changed. Now you can't change, okay, you changed it, fine. You want to change it. The next time you add the item, it would be added at the back, not the front. You didn't really want to add an item. You wanted to change the item. There is no such thing as change. You can only NQ or DQ. So you would DQ first, and then you would NQ a new item, and then reposition everything, basically. So you would take out the item, and then you would put the item back in, and you would do it until the size. This is basically restructuring the queue. It's basically you're recreating the queue. This is the initial queue, let's say 100, 20, 30, 40. Now you remove 100, you sold 50 of them, so you would get 50. Now this is actually wrong, you don't want 50K. So you would move each of the items back, and then you would have 50, 20, 30, 40. And that is correct, you've changed 100 to 50. That's it. That's the cell mechanism. We already did the buy mechanism. You can go through the code. And if you need the code, you can ask me as well. Okay, let's try to run it. So I want to buy 100 at $5. Mm. Oh, I missed something. I want to buy 100 shares at $5. Okay, so you've added the share and the price. And basically they're linked to each other, they're together. So you add together, you DQ together, or you NQ and DQ together. Or you offer and poll. Sorry, you don't poll, you offer together. And yes, you do poll as well. Poll is to remove. Yeah. Let's buy one more. Buy 200 shares at 60 each. Let's try to sell the shares. Let's sell 30 at. Now this would only sell the ones at the back, or the ones which you bought the oldest. So now you've lost $90. All right. So you have your capital gain, you have everything you need. The queue is also updated, as you can see. And the output format is also different. So that's it out for today. If you guys have any questions on this, what poll offer, these are all operations. So we have poll offer as well. And you can compare, add, remove, what these have in, what differences do they have? Okay. Okay, yeah, that's it.